So, greetings, students. So, in today's lecture, we'll be dealing with your fast decouple method. Okay, so load flow analysis for your fast decouple method we'll be seeing in today's lecture. So, in the last lecture, what we have seen was we have seen about your decouple method. So, in the last lecture, we have covered your decouple method. So, as per your decouple method, so what is the final equation you will be getting is that there will be a weak coupling. Okay, there will be a weak coupling with respect to your reactive power and your voltage angle. Okay, so as per the weak coupling, what you will be getting is you will be getting the equation to be del P del Q, which will be equal to, and I will be getting J1, J2, J3 followed by J4. Okay, this will be equal to del del followed by your, if it is a PV bus means you have to like this, uh, del V. Okay, so this is nothing but this represents your change in voltage to the voltage magnitude, so you will be getting your voltage magnitude only. Okay, so over here as per the decoupling methodology, what you will be getting is your J1 and J2 will be cancelled out. J2 and J3 will be cancelled out, and hence you will be getting del P del Q should be equal to J1, and over it will be 0 0, and over it will be J4. So we have seen how this happens 0 0. So due to the weak coupling concept, so that we have seen with respect to your previous lecture. If you want, you can just go through it. And over here you'll be getting like this. Okay, for easier representation, we'll be changing the these values will be changing to some other variable. So over here, instead of having as j1, j2, j3, j4, we will be having it as h, n, m followed by l, h, n, m, l. Okay, and over here we are having the value of h and l. So your n and m is 0. Okay, if you are representing the equation with respect to your h and n means, so this equation becomes like this. The magnitude of del P will be equal to magnitude of H into del del, okay, del del, and after that will be del Q, which will be equal to L followed by the voltage, which is nothing but your uh, del V over magnitude of V. Okay, so this is what you will be getting in your decouple method. So this is what you'll be getting up to your decouple method. So regarding your fast decouple method, this is what you have seen until your decouple method. Regarding your fast decouple method, we will be making use of some more assumption. Okay, we will be making use of assumption. Okay, we will be still more making use of some assumption in a far faster convergence, not to achieve faster convergence rate. Okay, not to achieve a faster convergence rate, we will be further making assumptions in your decoupled method. Then the respective method will be called as a fast decoupled method. Okay, so we'll be dealing with it. So before getting into that, you have to know about uh, the recall some things what you have seen with respect to your NR Newton raftion. So as I said, this fast decouple is nothing but an extension of your Newton raftion. except you will be having some assumption over it. Okay, so coming to the next point, and here we'll be considering some equations from your fast sorry, Newton Raphson method. Okay, so what are those equation means? Those equations will be contributing for your H, okay, which is nothing but your J1. Okay, your H or J1, this is nothing but will be equal to your, so it has both the things, right? It has both the things, diagonal element followed by a off diagonal element, diagonal element followed by a off diagonal element. So over here, okay, there exist two elements, this you know. So the diagonal element is nothing but your dou pi by dou I. If you are taking in the seeing your Newton Raphson methodology, you can get to this point. Okay, and over here it will be OPI by del J. It will not be I, it will be J. And over here the condition is I not equal to J. Okay, and now we will be defining this. So over here, as per what we have defined, your H, which is equal to, okay, your H, that is your H, you have to say it as HII. Okay, your HII is equal to uh, this value dou pi by dou del I, so which will be equal to the of what we have seen in your Newton Raphson. So J will be not equal to your I value since it is a diagonal element. Okay, and over here you have to make it Vi over Vj. Okay, Vi over Vj, and then followed by your admittance Yij. Okay, Yij, and followed by sine theta ij minus del I plus del j. So this is the element what you'll be getting for your diagonal element. This is the element what you'll be getting for your diagonal element. Okay, and over here you have to make the first assumption. So the first assumption is that the first assumption is that your, so here you will be getting okay, so your first assumption is that you have to consider where del I, okay, where del I minus of, where del I minus of del j, which is equal to, okay, that is, sorry, this value. So del I is del j, this will be equal to your del I j. Okay, this one you have to put over here, this one you have to put over here. So what you'll be getting is, you'll be getting HII will be equal to OPI by del I, which is equal to j not equal to I. Okay, so Vi Vj Yij. Okay, so this becomes sine theta ij minus your del ij. So now you have to apply over here the formula of sine a minus b. You have to apply. Okay, if you're applying sine a minus b formula means what you'll be getting is, so you'll be getting the value of sine a cos b. Okay, so you'll be getting, you have to put this formula. You'll be getting sine a cos b minus cos a sin b. Okay, so if you're putting that formula means you can just refer the formula and you can do it. So if you're putting that formula means you'll be getting the value of hii to be h will be equal to, so after putting this you'll be getting, after putting and substituting the values. Okay, after putting and substituting the values, you will be getting as uh, plus v square. Okay, plus v square, that is vi square. Okay, followed by, okay, so followed by v square and followed by your admittance yii. Okay, yii followed by sine lab followed by sine theta ij. Okay, followed by minus v I square. Okay, the same thing coming out into a v ij. Okay, into sine theta ij. Okay, so minus summation vi. Okay, vi into your vk, that is sorry vj into yij. Okay, and over here it will be sine del I minus del j minus theta ij. So this is the thing you'll be getting. So how if this is coming out means by expanding your sine theta formula. Okay, and over from here what happens is you have to substitute the value of your y, that is your y I can be written as gii plus jbii. Okay, that is, this is represents your admittance, this represents your admittance. Okay, this represents your admittance followed by your admittance. Okay, uh, followed by G represents your conductance, and B represents your susceptance. Okay, so this is regarding your magnetic circuits. Okay, susceptance is based upon your magnetisms. Okay, so if you're writing this means this real part corresponds to your conductance, and imaginary part corresponds to your susceptance. Okay, on solving this equation, so your H11 HII value, what you'll be getting is, I'll be writing directly. Okay, so HII will be equal to your VI square BII minus QI. Okay, so this is the thing what you'll be getting with respect to your H, that is HII. Okay, and regarding your off diagonal element, okay, regarding your off diagonal element, what you'll be getting is H I J is be equal to Vi, okay, Vj into Yi J, okay, followed by sine del I minus del J minus theta Ij. Okay, so now you have to put again your del J will be equal to del Ij. Okay, you have to put here and you have to solve it, so you'll be getting Hij will be equal to Hij will be equal to uh, this one Vi, okay, Vj and Yij into this, you have to expand, you'll be getting sine del Ij minus cos theta Ij, okay, and minus of cos del Ij minus sine theta Ij. So this is the thing you'll be getting. So upon solving, what you'll be getting is Hij will be equal to Hij will be equal to Vi, okay, Vj, okay, into, so first you have to consider a real part of your admittance matrix, that is your Gij into sine del Ij, okay, minus Bij, okay, into cos del Ij. Okay, so this is what we will be getting as a off diagonal element. So the same thing is applicable for your L value. So for the L value, what you will be getting? So L value is nothing but your, the L value you have to consider to be as your J4. Okay, so your L value is your J4. So this J4 will be equal to, so this J4 will be equal to I think what we have seen in NR. So as per it, it will be del Qi by del Vi. Okay. So again, this is your diagonal element. This is your diagonal element, and how you can write this diagonal element as, it will be coming like this. It will be writing, so 2 pi yii sine sine theta I plus summation pj, okay, to yij into sine of del I minus del j minus theta ij. Okay, so this is the value for your L. Okay, so the same thing what we have seen before you have to consider, and so you will be getting the, this is LII value. So your LII will be equal to 2 V I square YII, okay, into sine theta II, okay, plus summation Vi Vj into Yij, okay, so sine del I, so here comes I, minus del j, okay, so here it will be coming into, okay, minus, so minus theta ij, okay, so this is for your off diagonal. So upon simplifying, and over here also upon simplifying, what you'll be getting is, here it is a v, we are taking it as the same, means we'll be getting it to be bi square, okay, vi square, okay, then followed by, over here you're just putting your I equal to j over here. So if you're putting, means vi square, okay, so followed by bii, okay, bii minus qi. So your qi becomes, be coming with this formula. So if you want to just refer with respect to your nr, so this, the remaining element, except these, the remaining element will be there, right? That those element will be contributing to your reactive power. The same thing comes over here also. So here this becomes I equal to j, okay, so this becomes vi square bii plus qi, okay, plus qi. So now we got the formula for a li. So now we have to consider your assumptions, okay, and for the assumptions, what are the things you have to assume, means assume assume cos del ij to be 1. Okay, it is first assumption approximately equal to 1, then followed by sin del ij to be 1. Okay, and finally your gij, okay, your gij into sin del ij, that's the real part, okay, will be less than or equal to your bij. Okay, so these are the assumptions. So after those assumptions, how your diagonal and off diagonal element changes means, okay, how after this how it changes means, so it changes in this fashion. Your h I j will be equal to, that is your off diagonal element, and there's another one assumption, your reactive power must be less than or equal to your reactive power qi must be less than or equal to bii into vi square. Okay, and so after this how it becomes means, h I j will be equal to minus vi vj into bij. After this h I will be equal to vi square bii. So after this your l I will be equal to vi square into b, the same value, and finally your Lij will be equal to vi square, okay, into bij. So this is the value of your h and l. We have got the h and l, so put the values of h and l. So put the values of h and l in the power residue equation. The power residue equation. So what you will be getting is, you'll be getting the final equation as final equation. What you'll be getting is del p by magnitude of v, which is equal to b dash into del, and your reactive power del q by del v, sorry, del q by v, which is equal to b double dash. Okay, so this is how it becomes, and over here this b dash and b double dash represents, these represents constants. Okay, these are constant they represent the constant approximation constant approximation to the slopes of tangent tangent hyperplanes hyperplanes of function del p by v and del q by v. Okay, so this is what regarding your fast decoupled methodology. So over the fast decoupled methodology, the solution might converge. The solution might converge within two iterations. Okay, converge faster since due to the methodology used over here. That is many things you have assumed over here, right? So hence your method nearly converges 2 to 5 iterations fairly. Okay, it gets converged within 2 to 5 iterations. Okay. Also, the speed is also 3 to 5 times greater than that of your Newton Raphson methodology. This is what regarding your fast decouple methodology. So it is just an extension of your Newton Raphson. Okay, you have to know about decoupling, then this methodology will be easy. Okay, you can also refer to your PS Murthy book. The same methodology will be used over there also. Okay, so with this you can stop today's lecture. So thank you.